I'm going to go over 12 through 15 is where you're going to write it as a system of matrices. You aren't solving, all you're going to do is write it. So this is an example for 12 through 15. And that's a normal system of equations, right? Which you've used to solve by substitution, by addition elimination, by Cramer's, and eventually we're going to get by matrix algebra in a minute. So first you have what I call are the coefficient variables. The coefficients of x's and y's go in a matrix. What variables am I solving for? X and y go in the second matrix. This is times equals the constant matrix. So what are my constants? And that's it. That's all you do on 12 through 15 is get it set up. So you have a coefficient matrix. You have the variable matrix. And then you have the constant. Now my next example, there's something wrong. What's wrong to begin with? What do you guys notice?
You have to have the constant by itself.
Right. It's just like with Cramer's rule. Your variables have to be on one side and your constant has to be on the other side. So we have to get that done. So what would I do to get 5a
Subtract 2b.
subtract 2b, so it's over with the a? That becomes 5a minus 2b equals 8. What about the second equation? Add 4. And what else do I need to do there?
Make sure it's the same.
Make sure I line them up, right? So the negative 2a should be listed first, then plus 3b, and then adding 4 gives me just 4?
Do you necessarily need to line them up, or?
Yeah, well, as long as you know. It's easier if you line them up, because this has to be x, this has to be y, or they have to be in the same position. Do you understand what I'm saying there? Okay, so what is our coefficient matrix going to be? 5,
2, 1, negative 2,
and 3. What variables are we solving for? A and B. And what will it be equal to?
8 and 4.
Is everybody okay with what you're doing on 12 through 15? Okay, now, leading into the next group. Don't need to write this down. What do you do to solve that for x?
Times 5 times yourself.
Multiply by 4 over 1. Why? What's this called? Technical name is the multiplicative inverse, right? Which you call the reciprocal. So then this cancels and we get x equals, because this becomes what? 1, which is the identity for multiplication, right? Get all our property rules back in. And then over here we'd end up with 12 over 5, and that would be our answer. We're essentially doing this. You're doing algebra to solve a system of equations using matrices. Now, in addition to using your algebra skills, you're also going to have to use a skill from last Thursday and Friday. How do I find, and you don't have to write this down yet either, we're going to put it into play. I'm just kind of reviewing. How do you find the inverse of this?
Multiply by the diagonal.
Well, first you find the determinant of that, which is
14 minus negative 15 equals 29.
so you get 1 over 29. Then what did we do to these two?
Swap.
Swap them. And these two? Change the signs. And this is classified as the inverse, right? Multiplicative inverse, which is what you'll need to know in order to be able to get the identity, which will be able to get you solved for x. Okay, so now, let's do an example. And this one you can write down. So this is for 26 through 31. Now every one of these you're solving for x and y, or a and b. You're solving for a system. You need to show all your steps to get there. So let's start with one that comes out fairly nice. So the first thing we need to do is to write it as a system of matrices. So Mary Lynn, what's going to be our coefficient one?
3, 2, 1, negative 4.
Okay, and Riley, the variable one,
Oh, X and Y.
right? And Carissa, what is our constants?
8, negative 2.
Now, what did we do to solve? To solve for x, right? You multiply by the multiplicative inverse, right? We're solving for x and y at the same time. You're still going to multiply by the multiplicative inverse. So that means we got to multiply both sides, and anytime you do something in algebra, you do it to the same side. But since we're with matrices, you got to be very careful. We need to multiply to the left. Remember I told you that last week? So we want to find the inverse of this. So Josie, what would be the determinant of that first?
Negative 12 minus 2 is 8, negative 14.
Okay, so we're going to have 1 over negative 14. Then inside, what are we going to have? Handle it.
Negative 4, and negative 1, and negative 2. Oh, sorry. And, 3.
Now this I'm just rewriting because that's like having the 1/4 x. I just rewrite it. Now here's what I'm going to do to emphasize to you that we're doing the same thing to both sides.
What are you doing?
We're multiplying this by its inverse because when we showed that example, 1/4 x equals, I don't remember what it was now. Didn't we multiply both sides by the inverse? So that's what we have to have. Now, I did a squiggly line under it. Everybody agree that that's the inverse? And don't we know when you take an inverse times the original, you're going to get the identity? Which we'll prove it on this one to show that it does. But we said this always has to be to the left. So over here, notice, my 4 over 1 is to the left, but on this one is to the right. In matrices, it has to be on the same side. So I've got to write this down on the left. So all I'm doing is rewriting what I have there. And again, I'm doing the squiggly line underneath it. That emphasizes the algebra. In algebra, you multiply both sides by exactly the same thing. Or whatever you do the same thing to both sides. And in matrices, you got to be extra careful, and you got to do it to the same side, in this case, the left. Does everybody follow what I'm saying there? Okay, this is the inverse, so that's the key. We know that when you take an inverse times the original, you're going to get the identity, which is 1. Which 1 times x is just x. So that's what we're trying to do, is we're trying to solve for x and y.
I don't understand how we're solving for x and y.
We're using a process called matrix algebra.
I don't understand that.
Okay, you will when we get finished. Now, does everybody agree that we've got the inverse on both sides?
Yes.
Okay, now, this part, at some point, this you know should end up being what? The identity. And we mentioned this last week. I showed you an example. The identity in matrices ends up being where 1s are in the diagonal and 0s everywhere else. So you know you're going to be right if you get that on this side. Okay, now let's try that. So we multiply our matrices. Where are we at? Okay, you get to row 1, column 1 when you multiply. What would you get?
Negative 12 minus 2.
Okay, and Dylan, you get row 1, column 2.
-8, or is it 8?
Nicholas, can you do row 2, column 1?
Fine.
Okay, we'll wait.
What is the...
We multiplied row 1 times column 1 and row 1 times column 2. Multiplication of matrices is row by column. -12, -2, -8, +8. That's where those numbers came from. Then we're ready for you to do row 2, column 1.
-3, 5, +3.
Right. Okay. Spencer, what about row 2, column 2?
-2 minus 12.
Okay, now, when we get this added, what do we get inside? A -14, 0, 0, and a -14.
What?
I just added them. -12 and -2 is a -14, a -8 and 8, 0, -3 and 3, 0, -2 and a -12 is -14. Now, if you multiply by the scalar, what are we gonna get?
One.
1, 0, 0, 1, right? And what do you know is true? So this, when we multiply, it all condenses down to the identity, which that means we've done things right to this point.
What do you mean multiply by the scalar?
That scalar right there, the number out in front, we call a scalar. It's really just like distributive property. They call it scalar multiplication with matrices, but you can also just call it distributive. Now, what happens when you take an identity times x? What are you going to get? The identity here is 1. What's 1 times x? So what's the identity times xy? xy. So essentially, this side is finished. We've got this side all the way done.
So do we even need to write any of that line for any of the identity for it?
Wait, and I'll show you what we're going to do. But right now, we're proving it, that it does work. Okay, on this, what are we going to do to solve it? What did we do to solve this answer up here? 2/5 times 4 over 1. Didn't we have to multiply? Same thing here, you got to multiply. Row by column. So let's see, I think we're ready for Robert. What's first row, only column?
-32 plus 4.
Okay, and Nathan, you get second row in that only column.
We'll have -8 minus 6. What are we doing?
Multiplying row by column. -32 plus 4, -8 plus -6. Aaron, what do you get when you add these together?
28.
I'm trying to.
-2. -28, -2.
What's a -8 and a -6? Signs are like you add and keep that sign. So -14?
Yeah.
Okay, now we multiply by the scalar. So what do we get when we multiply by the scalar? What's a -114 times a -28? 2. What's a -114 times a -14? So we just found our answers. 2 and 1.
How do we know what y and x are equal to?
Right straight across. Remember we did equivalent matrices the very first assignment in this chapter. The position is equal to the same position in the second matrices. So x equals 2, y equals 1. Okay, next example. And we'll do one that doesn't come out so nice this time. That one I made sure it came out okay. And okay, so we're back to Marilyn. You get to tell me the coefficient matrix.
4, 5, 2, 3,
And the variable one? Riley?
X and Y,
X and Y. And the constants?
1 and 4.
1 and 4.
I haven't got any of this
Now, what's the first step in solving?
Inverse.
Find the inverse. When you find that inverse, it's going to be multiplied by both sides to which direction? The left. So give him time to get that written down. Is everybody ready? Okay, so we want to find the inverse. So let's see, Dylan, what would be the determinant of this one?
-12 minus 10, which is -22.
Okay, so we put 1 over a -22. Nicholas, what's going to be the inside of our inverse?
It's going to be -3.
or just tell me what you get?
-2, and then -5, and 4.
Okay, yes,
Yeah, no.
we're okay? All I'm doing right now is recopying. Now I'm to the other side, so I've gotta do what we're doing. Now, my main question, have we done the same thing to both sides?
Mhm.
And that's what algebra's about, doing exactly the same thing to both sides. And we did it to the left since we're in matrices. Now, we just showed a while ago that when you multiplied an inverse times the original, what do you produce?
1.
You get 1. Does everybody agree? But 1 is really called the identity, right? And the identity, don't we know when I take this times this, I'm gonna get 1, 0, 0, 1?
Yes.
Okay. Now, do you guys concur that's gonna be true?
Yeah.
Now, the only real work you have to do on matrix algebra is not on this side, but on this side. Did you find that when we did that example, the very first example? That was where the most work, that's where your answer comes from. So we're ready for Spencer. You're gonna get row 1 times column 1.
-3 minus 20.
Okay, and Robert, you get row 2 column 1.
-2 plus 16.
Now, what do you know that the identity is times the variables? What is that gonna be? It's just gonna be the variables.
So why would we even write that entity?
Because you're solving for it. It's just like in algebra, don't you leave your x in the problem?
I don't, no, we don't do the 1, 0, 0, 1.
I want you to show me that that's the identity, unless you want to do all that multiplying and do it.
Like usually when I do mine, I don't write 1.
I know you probably don't in the algebra expression, but I want you to show that. Either that or you can do the long multiplication and do it by showing it that way, or do the alternative. Okay, what do we get here? When we add these numbers together, we get, and let's see, Nathan, why don't you multiply by that scalar, the distributive property of it, what do we get?
Well, 23 over 22,
23 over 22
and -14 over 22, which will reduce.
to what, 7/11?
Yeah.
7/11. So what did we get for answers?
23, 22, and -7.
And I'll ask you this, we got answers that weren't very nice, right? Did we really have any problems working with those answers that weren't very nice? If you did substitution or additional elimination, you would, because you'd have to substitute it back in and do the solving. Now, here's one thing, you guys that have your calculators out. If you don't have a calculator out, that's okay. Let's see if it works. What's 4 times 23 fraction key 22 plus 5 times -7 fraction key 11, and hit equal and see if you get 1.
You do.
Could you check it with the next one too?
Yeah.
2 times 23 22nds, the fraction key makes it very easily done on a calculator. Minus 3 times -7 fraction key 11, and hit equal, and hopefully you get 4. So you shouldn't have to miss any, because you can check them if you want to. Could you check if it's on a test? Could you check by using Kramer's rule, substitution, additional elimination? Is that another alternative?
Why wouldn't we just use elimination here?
Because I want it done by matrix algebra. I want you to learn the new method. Okay, now here's a third example. You don't have to write it down. Just to make sure you get it, let's go with okay, I think we're at Aaron. What's the coefficient matrix?
4, 2, 1, -5.
And what variables are we solving for, Mary Lynn?
X and Y.
And Riley, what are our constants?
4 and 3.
1, 3. Okay, so Chrissy, you get to find the determinant. So what would be the determinant?
-20 minus 2,
That would be,
negative 22.
we're gonna have 1 over negative 22. What's gonna be in that, inside of that matrix, Josie?
Negative 5, negative 2, negative 1.
Now, does everybody agree that that's the inverse?
Mhm.
So each side has to be multiplied by the inverse. All I'm doing is rewriting. And I gotta do it to the left. Okay, now, Evelyn, what do you know happens when you take this inverse times that original matrix?
It gives you 1, 0, 0.
And I'm letting you guys skip that multiplication process. You guys realize that happens. And inverse times original is gonna be the identity. Okay, then Tatum, on the other side,
You're gonna have to. do-
row by column.
So it'd be negative 20 minus 8.
What about 6?
Oh, sorry, I was looking at 4. Minus
That's-
6.
That's right, you gotta move.
Mhm.
Okay, Dylan, you get row 2 times column 1.
Negative 4 plus 12.
Okay, then Nicholas, what do you know when you take the identity times the variables, what are you gonna get?
1, well, like the variable.
The variables. 1 times anything's at anything. And let's see, Spencer, what's those add up to be?
Negative 26 and 8.
And then Robert, you get to multiply by the negative 1 over 22.
Okay, so it'd be 26 and 22.
Which reduces to 13/11,
Yep. And then it would be 8 over, negative 8 over 22.
which reduces to 4/11.
Yeah.
So our answer is 13/11 and negative 4/11.
Mm-hmm.
Do we need to restate our answer like that again?
No, I can see it here too, I'm just emphasizing that it is a system, so it's x comma y. Did anybody check it to see if it worked? And to check it, you'd go 4 times 13 fraction key 11 plus 2 times negative 4 fraction key 11 hit equal, and it should equal 4 if you've done things correctly. Okay, does everybody understand what you're doing there? So again, repeat, 12 through 15 are you solving?
No.
All you're doing is writing is coefficient, variable, constant matrix. The next group, 23 through 31, you're writing it as matrices, and then you are solving for each and every one. So the first problem I want to see is number 26. Because that first group, 12 through 15, is just writing, and I can check it quickly when you show me number 26. 26 is the first of your solve. Does anybody have questions on what you're doing? Okay, somebody turn off the video.